Hello everybody, welcome back to Dave's Math Videos. My name is Dave, and today we'll be looking at this statement here. 1 over y plus 1 over x is equal to 2 over x plus y. Now, as you probably know, and as you probably learned in school, this statement is false. When we add fractions, we cannot simply add the numerators and the denominators like we see here. Instead, what we need to do is basically what we learned when we added fractions using numbers. That is, we're going to find a common denominator. In this case, our common denominator is x times y, and then we'll multiply the first fraction by x over x and the second fraction by y over y. And only when we have a common denominator can we add numerators to get x plus y over xy. We could also prove that this statement is false by using a simple counterexample. In math, if one counterexample is false, it proves that this is going to be false if you consider all the real numbers. So if we let y equal 3 and x equal 2, then we are going to add 1/3 to 1/2. And the result of this is 5/6, and of course not 2 over 5. However, we can also ask, are there values for which this statement 1 over y plus 1 over x is equal to 2 over the quantity x plus y is true? Now, it might not be true for all values, but there could be conditions under which this statement is true. Now, in order to do this, we will set x plus y over xy equal to 2 over x plus y. We can cross multiply and we'll get 2 times xy is equal to the quantity x plus y squared. Next, if we expand the right-hand side and eliminate the 2xy, we will get y squared is equal to negative x squared. Now we're going to assume that x and y were both real numbers. That being the case, the square of any real number is positive. Hence, y squared is positive. And likewise, x squared is positive, which means that negative x squared, negative 1 times a positive number, is going to be negative. What this means is that there is going to be no solution in the real numbers, but one will exist if we can use complex numbers. Therefore, we can take the square root of both sides, and y is equal to plus or minus the square root of negative 1 times x. Now, the square root of negative 1 is I, so we get y is equal to plus or minus I times x. And this is going to be our solution. Hence, we could say that 1 over y plus 1 over x is equal to 2 over x plus y if and only if y is equal to plus or minus I times x. So now let's go back and let's try to solve this in reverse. In other words, we are going to prove this statement. One way to prove something in math is to show that the left-hand side is equal to the right-hand side. So let's begin by computing the left-hand side. We will say that 1 over I times x plus 1 over x is equal to 1 over ix plus I over ix. Adding these two together gives us 1 plus I over ix. And if we want to rationalize the denominator, we'll multiply the top and the bottom by I. This gives us I plus I squared over I squared x. However, I squared is simply negative 1. So after some simplification, we get 1 minus I over x. Now, let's take a look at the right-hand side. Again, what we'll do is we'll input I over x instead of y. If we do this, we get 2 over x plus ix. What we want to do now is we want to rationalize the denominator. To rationalize the denominator, what we'll do is we'll multiply the top and the bottom by x minus ix over x minus ix. If we do the algebra, we'll eventually come to 2x times 1 minus I over x squared minus x squared. And this gives us 2x times the quantity 1 minus I over 2x squared. Now we can cancel a 2 and an x, and we will get 1 minus I over x. So as we can see, the left-hand side is equal to the right-hand side, which proves that this identity is true. So again, this statement, 1 over y plus 1 over x, is equal to 2 over x plus y if and only if y is equal to plus or minus I over x. Thank you for watching this video, and if you found the content in this video helpful, please help my channel out by liking the video, subscribing, or commenting. Thank you very much, and I'll see you in the next video.